We built this city. We built this city on rock and roll. Built this city. We built this city on rock and roll.
Hey, it's the Geek. Today's objectives are to understand the properties of a covalent bond and to demonstrate how to model covalent bonding using Lewis dot diagrams.
Okay, so first of all, what is a covalent bond and how is it different from an ionic bond? There's two main differences. Firstly, covalent bonds only happen between two nonmetal atoms, as opposed to a metal and a nonmetal with ionics. Also, these nonmetals, they share electrons between the two. There's actually no transferring electrons like with ionics. With covalents, you can also have single, double, and triple bonds. Since each bond holds 2 electrons, singles can hold 2, doubles 4, and triple bonds can actually hold 6 electrons.
Alright, so this is an animation of covalent bonding, which is sharing electrons. You can see that both atoms have 7 valence electrons, and in order to get an octet rule between both of these atoms, they must share one. So every time you see them come together, they're sharing that electron, and then they stick together in a covalent bond.
Okay, so chlorine, which forms the molecule Cl2, is going to be our first example. A chlorine atom will actually form a covalent bond to itself. Here's the process of how that happens. Remember, each chlorine wants to gain 1 electron to achieve an octet. The way chlorines are going to do that is actually by moving close enough together until, you can see that process again, until those electrons, which used to be alone, now form a pair in between the 2 chlorines. The beauty of that is, if you draw a circle around one of these atoms and count the electrons, this chlorine, which used to have 7, now has access to an 8th from the other chlorine, making the octet. Same thing with the other chlorine. Draw that circle, used to have 7, now it has 8, so this chlorine also has an octet, so we've fulfilled that bonding rule called the octet rule. Of course, this is achieved by each atom sharing the electron pair in the middle. Keyword is always going to be sharing when it comes to covalent bonds. Here's that circle one more time. If you draw both circles where they overlap the 2 electrons in the middle, that's technically what creates the covalent bond. And because it's only 2 electrons, we call this a single bond. This single bond might also look more familiar as a dashed line. You just have to remember, when you see these dashed lines, that always represents 2 electrons being shared between the atoms.
So I'm going to briefly go over the steps for drawing covalent bonds. There's 4 steps that I want you guys to know, and the first one is to make sure that we only have nonmetals. So I show you nonmetals for the chlorines. The second step is to draw the valence electrons, also known as a Lewis dot diagram, around each. We have 7 for each of these. The third step is to identify the lone electrons that will need to be paired. These are electron pairs. These are lone electrons, and usually when you see electrons that are alone, it's going to need to be bonded in some way, either ionic or covalent. In this case, it's covalent. The last step is to show the covalent bond, and that's just a dash. We do not need to draw the electron pairs around the chlorine because they're just assumed that they're there. We're really just concerned with the covalent bond.
Okay, so here's a different example. We're going to look at O2. Oxygen also forms a bond to itself. Here's the steps you should follow if you have to draw this molecule. Number 1, make sure they're only nonmetals. Good. Oxygen is definitely a nonmetal. Step 2, put in the valence electrons. Each oxygen has 6, so they should both look like that. Step 3 is you got to find the electrons that are alone, not in pairs, and you pair them up. For oxygen, it has 2 electrons that are alone, so it's going to form 2 pairs. Remember, each of those pairs forms a bond, so the final step is to rewrite this, except don't draw them in pairs, represent it as 2 little dashed lines. The 2 dashed lines go between the oxygen symbols. Remember, each line represents 2 electrons, so that double bond actually contains 4 total electrons.
Our next example is N2, which is 2 nitrogens. Step 1 is to make sure we only have nonmetals. They're on the right side of the periodic table where the nonmetals are, so we could check that one off the list. Step 2, draw the valence electrons. There are 5 valence electrons for each nitrogen. Identify the lone electrons that will need to be paired. There are 3. Rewrite it. We have a triple bond. Remember that triple bond holds 6 electrons. Uncle George says this is so cool, and I happen to agree. In today's tutorial, we understood the properties of covalent bonds. Remember, we're sharing. Sharing is caring. A purple dinosaur once said that, and it's the same thing that we're talking about here. The art of sharing. It's a beautiful thing. Demonstrate how to model covalent bonding using Lewis dot diagrams. We showed you 4 steps. It's the 4 easy steps to drawing covalent bonds. So if you have any questions on these, bring them to class tomorrow. We'll be hanging out with George Washington in the front of the class.